Welcome back to Math 109 Plane Trigonometry. In this video, we're going to take a look at Heron's formula, which will allow us to find the area of a triangle, given only the three side lengths, not knowing anything else about the triangle. So we're first going to define the semi-perimeter of the triangle. That's going to be S. And that will be 1/2 multiplied by the sum of lengths of the three sides, which we're going to call A, B, and C. So now, under Heron's formula, the area of a triangle will be area, and I should use script A here so we don't confuse it with the angle A, is equal to the square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. So all of that is underneath the square root. And the derivation of this is in your textbook. It is about a page and a half of boring mathematics that I am not going to put you through, but if you want to read it, you can find that derivation there. Just as an example of this, to kind of motivate that this will work, I'm actually going to use a right triangle with side lengths of 3, 4, and 5. My reasoning behind doing this is that we know we can use the standard 1/2 base times height to find the area of this triangle. But first, let's look at it with Heron's formula. So in this case, our semi-perimeter S is going to be equal to 1/2 times 3 plus 4 plus 5. That's half of 12, or 6. So now we can apply Heron's formula. We get the area is equal to the square root of 6 times 6 minus 3 times 6 minus 4 times 6 minus 5 and then I can go ahead and simplify within those parentheses. We get 6 times 3 times 2 times 1. I multiply all that together. I get the square root of 36, which is equal to 6. And just to verify this, if I use 1/2 base times height, I get 1/2 times 3 times 4, which is equal to 1/2 of 12, which is equal to 6. So this does verify in the case of the right triangle. And like I said, it does work in general, but the derivation of this is a page and a half of long, boring mathematics that I'm not going to show you. So this is Heron's formula. We can use this to find the area of any triangle given its three side lengths. So that's all we're going to cover out of Chapter 7 of the text. In Chapter 8, we're actually going to apply what we've learned in this course about trigonometry to the complex numbers and come up with nicer ways of multiplying them than the standard use of algebraic methods that you learned in an algebra course.